Hi, we are going to talk real quick about two things, reciprocals and a new formula for area of a triangle. So reciprocals of the trig function, remember reciprocal just means flip it, right? So where sine is opposite over hypotenuse, OH, SOH, if we talk about this new thing called cosecant, it's the flip of sine. So instead of it being opposite over hypotenuse, it's hypotenuse over opposite. And there's some reasons down the line where you might need to flip the things. It's just another tool to put in your toolbox, okay? But for now, we're going to learn how to use or how to understand that tool. Later on, you'll get to learn how to use it. So, and cosine has a reciprocal, and it's called secant. You flip it. Tangent has a reciprocal, and it's called cotangent. And you'll notice I wrote out the whole words here so you can see what they look like if you write out the whole word. But if you see these abbreviations, CSCX, that just means cosecant of your angle x. SECX does not mean other things. It means secant of x. And COT does not mean you're taking a nap on a cot. It means cotangent. It means flip tangent. Okay, so all that said, we're going to have a couple examples where first we solve for something, solve for one of the sides or an angle, and then actually write out the reciprocal trig functions. We got to remember sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So it says find x. All right, well, let's label some stuff, right? So let's see. According to this angle here, this 23 would be the adjacent side. Right, caps. Oh, sorry, the caps. There we go. That'd be adjacent. And this side up here is your hypotenuse. And so which one of these uses adjacent and hypotenuse? Well, that would be cosine, right? That'd be cosine. So cosine is adjacent over hypotenuse, as you remember. So if we're going to do cosine, we need 23 over x in this case. And it's cosine of your angle. And in this time, our angle is 55. So we're going to have cosine of 55 equals 23 over x. Then to solve that, we're going to switch the places, right? When x is on the bottom, we can switch the place, not of x and 55, but of x and the cosine of 55, okay? So when we do that, we pop that into a calculator, right? We switch the place and we get x equals 23 over cosine of 55. We pop that in the calculator, it tells us that it's about 40.09. They told us to round to, or they didn't say it on here, but we want to round to one decimal place. So it's about, well, we'll just say whole number. So it's about 40. Okay, move this over just real quick. All right. So it's about 40. All right, done. We got that. This side over here is about 40. Okay, so since we know that that side's 40 and this side's adjacent, we're set. It says write the reciprocal trig equation. Okay, we want the reciprocal of cosine. And if you look at the front of the top of your page, the flip of cosine is secant. Okay, so cosine's adjacent over hypotenuse, secant is hypotenuse over adjacent. Well, our hypotenuse was 40 and our adjacent is 23. So secant is going to be 40 over 23. That's going to happen again here in a second. Now we're going to do the same idea over here. So we're going to start by solving for what they tell us to. This time it's an angle. Remember, when you're solving for an angle, you're going to have to use the inverse of tangent. Okay. So the first thing to remember is that me zoom in just a wee bit. We got to label everything. So this is the opposite leg. This is the adjacent. Since it's O and A, now we know we're going to be using tangent because that's OA. So tangent of our angle that's missing, call that theta, is opposite over adjacent. Then to actually solve for an angle, remember, to find an angle, we use the calculator, we use the second button or the inverse button. And on Desmos, you pop that in. I'll show you on Desmos how to do that. Let me open that up. On Desmos, the way you do inverse is we go into the functions over here, and then it's in Trig. So this -1, that means inverse tangent. And then I forget what we were doing the inverse tangent of. 20 over 12. Here we go. And it tells us it's about 59. Okay, 20 over 12 is about 59. Okay, so that means that my angle here, theta, is about 59 degrees. Okay. The next part, it says now find the reciprocal, write the reciprocal trig equation. Let me go ahead and put this in here, about 59. So we were doing tangent, so now we're going to do cotangent. Now remember, cotangent means flip your angle. Okay, and cotangent, means flip the ratio. So normally it's opposite over adjacent for tangent. Cotangent will be adjacent over the opposite. We got to put our angle in there, 59. But one thing I want to make sure we talk about here is cotangent versus inverse tangent. This is inverse, and this is what you use when you're looking for an angle. This is cotangent, and this is what you use when you're looking for the reciprocal. Angle, looking for an angle, looking for a reciprocal, totally different, okay? All right. And that is our reciprocal trig function. Okay, next part that we're going to try and do a little bit faster. Area of a triangle. Now I know you know an old formula for area of a triangle. It's 1/2 the base times the height. And the base and the height have to make it 90 degrees for this to work. But we're going to learn a new area of a triangle where we don't have to have a right angle inside there or outside. Okay, so this is the area of a triangle when you don't have a right angle anywhere that you know about. But be careful. Everybody sees these ABCs and they start thinking Pythagorean theorem. This is not about Pythagorean theorem. All right, so now we're going to find the area. All right, so the formula says the area of a triangle, if we don't know there's a right angle, then we're going to use the angle right here. We're going to take the sine of that angle, so 142, and we're going to multiply it by 1/2 times these two sides here, so 3.2 and 4.7. Now those two sides have to be on touching that angle that we're talking about, right? Another way to say touching is that the included angle, the angle between those two sides. And then we pop that into a handy dandy calculator, and let's see if I popped it in right or if I forgot something. No, we're good. I did it. 1/2 times 3.2 times 4.7 times the sine. And then it equals about 4.6 to the nearest tenth. So that would be about 4.6. That would be the area. And since these are meters, the units are going to be square meters, right? Area is always square units. So now we're going to do this other one. It says in some triangle, first of all, draw it. Okay, I'll draw a triangle. Any kind of triangle I want, just not with a right angle. And I'm going to call it D, E, F. And then they tell me that DE is 9, and that DF is 13, and then the measure of angle D is 57. So this guy right in here is 57 degrees. Okay, it says check that angle D is the included angle. Yep, that's the angle between these two sides that we know, so we're good, that is included. So now we're going to use our handy dandy formula that I actually forgot to write the half on. And in our handy dandy formula, it should say area is 1/2 times the two sides times the sine of the angle between them. Now we pop that into a calculator. I like Desmos. And it tells us that it's about, that the area of this one is about 49.1. And then we got to figure out what units. In this case, inches squared. Anytime it's area, your answer is square units. So inches squared. All right, there you go. There's a quick little video for you.